Okay guys, so this is a video that I'm making right here on this second class opener. Yesterday we had a class opener that was titled Review. This is review number 2. Tomorrow we're going to have a review 3. All these class openers are pretty much building up to the test that we're having Friday. I'm not sure, it might be a test, it might be a quiz. But what you see here on these questions, not all of them are going to be on the test, but let's say you see something on the homework, you see it again right here, that's a little sign for you to study it because it's most likely to be on the test. So we've had this type of question, number 1, many times. Now, we know that if you do not have parentheses around the negative, it's not really a negative 3 as the base. The base of this exponent situation is just 3, and there's a negative sign out in front. So I really have that negative sign out in front, and I have 3 squared, which is really 3 times 3. And of course, the answer is what? Negative 9. That's right. Now, it's a totally different story if you actually have those parentheses including that minus sign. So right here, the base really is negative 5. And when I write it 2 times, negative 5 right here, negative 5 right there, then I really do have negative 5 times negative 5, which is positive 25. Moving on to number 3. We know that it has parentheses, so the negative really is included, so the base really is negative 1. Okay, so if I were to write negative 1 times negative 1 times negative 1 times negative 1 28 times, I'm not going to do that, it's going to take too long, but if I were to write it 28 times, isn't it true that I'd be able to group them or pair them, right? I'll be able to pair them up. Because 28 is an even number, I'll be able to pair them up, say, oh, here's 2, here's 2, and you'll be able to pair them all up, and there's going to be no odd one out. They're even, so they're all able to be paired up. So when you pair them up, you'll have a negative times a negative, which is what? Positive. So all those pairs, you'd be able to pair them up into 14 different pairs. All those pairs end up being positive 1, which means that your answer really is positive 1. Okay? Now, remember, 1 times 1 times 1 times 1, 28 times is still 1, right? Now, it will be positive. Why? Because the exponent is even, which means that you'll be able to pair them up, and each pair gives you a positive, so the answer is positive 1. Number 4, a nice simple review question. Negative 6 minus a negative 4. We're not multiplying, we're thinking of money right here. We're combining these numbers. But before thinking of money, you have to change the minus minus to plus plus. You just have to do that. So we really have, you owe 6, you have 14. You owe somebody $6, you have 14. You can pay them off, you'll have money left over. How much do you have left over? $8 left over. Perfect. Number 5 is so easy that some people get confused, right? What do I mean by that? It's a fraction. Now, normally fractions are division problems. Like if it said 12 divided by 4, the answer would be 3. If it said 12 divided by 6, the answer would be 2. Oh, negative 2, because there's a negative out in front. But you have 12 over 21. You can't really divide 12 by 21. So that's a fraction, but the question is, could we reduce the fraction? Yes, we can. We could reduce by what? By 3. So I'm going to divide the top and the bottom each by 3, and I will get 4 up on top and 7 on the bottom, and that is my answer, 4/7, because I cannot reduce it any further. What about the negative sign? Oh, wow, thank you very much. The negative sign definitely belongs on that answer. The answer is negative 4/7. Thank you very much. So that was an example of me trying to work through this too fast, and I would get the wrong answer. I forgot the negative. You guys remind me. Thank you. So I want to repeat that question. That was a good question. You just asked, does it matter if the negative is right here in the middle or up here or down here? It doesn't really matter. You could actually move that negative. So notice I put the negative sign up here on the 4. Now that's totally fine. I could have written my answer as negative out here perfectly in the middle of the fraction, negative 4/7. So that negative could be written up on top or on the bottom or in the middle. Normally, we don't write the negative on the bottom. We either write it up on top or in the middle, okay? But either way is fine. But you cannot write it both on top and bottom. That would be wrong, because a negative divided by a negative is actually a positive, so it wouldn't be negative anymore. Make sense? Okay. So yeah, you could put the negative up on top. You could put it right at the center. You could technically put it on the bottom, but it's better to put it on top or center. Number 6, 2 times negative 6. 2 times negative 6 is? negative 12. Okay. Again, you need to remember that the only way you get a positive answer is if you have a negative times a negative equals a positive. Or what we've always learned, like, 2 times 6 is 12. Positive and a positive is a positive, right? So if the signs are the same, the answer is positive. If the signs are different, the answer is negative. That's when we are multiplying only. That means there's no sign between the 2 and the parenthesis. We're multiplying. So when there's no sign between it, when we're multiplying, that's when you could think a negative times a negative is a positive. Or you could go back to that story. If a good thing happens to a bad person, that's bad. Or if a bad thing happens to a bad person, that's good. Anyway, moving on. Number 7. Finally getting to combining like terms. Yesterday we started combining like terms, right? If I have 2 markers plus 3 more of those exact markers, how many markers do I have? 5. And in this case, we're not talking markers, we're talking X's. You could think whatever you like. You think dollars, bananas, oranges. But the idea is that you're adding the terms that are alike, okay? Number 8, we are not adding right here. We are actually multiplying, okay? Now, after all, we are multiplying between the 2 and the X. And we also are multiplying between the 3 and the X. And we're multiplying. So in other words, we're multiplying everything. Let me show you that. Everything's being multiplied. And in multiplication, there's this thing called commutative property of multiplication. You could switch the order, rearrange it. So I'm just going to multiply the 2 times 3 together, showing my work, and also the x times x together. So what's 2 times 3? And what's x times x? X squared. That's right. So some of us might be getting confused as to, well, why didn't this exponent up here become 2, and why did right here our exponent became 2? Remember, an exponent is really multiplication. Like if I asked you, let me just write this. If I asked you, what's 3 squared? What would you say? Is it 6? No, it's not 6. It's what? It's 9. Why? Because 3 squared means 3 times 3. So the idea is this. Multiplication is really exponents. Exponents really multiplication. So when you're multiplying, on number 8, you're multiplying. Yeah, exponents are going to change. But when you're just adding or subtracting, you're combining, exponents don't change. So that's why up here, exponents did not change because we were combining, right? 2 bananas plus 3 bananas is 5 bananas, not 5 bananas squared. That'd be wrong. Okay. Now down here, when you're multiplying, yeah, exponents really are multiplication. You're multiplying, that's why the exponent changed. Number 9, another one on combining like terms. That's a good one, but before even thinking of money or bananas or whatever you want to call it, you need to change any minus to plus plus. So let's do that. Change it to plus plus. And now let's combine like terms. And I like to circle things that I'm going to combine. And then after that, squiggly underline. And then after that, maybe like a box or a triangle. I don't know. Some type of symbol showing what I'm combining. So I'm going to combine this 2x, which is a positive 2x, with this positive 3x. So I have 2 bananas. I have another 3 bananas. That's a total of 5 bananas. In this case, x's, 5 x's. And of course, there's a minus 5 left over. Let me just slap that on there, and that's my answer, 5x minus 5. Because we can't really combine the 5x minus 5, we're done. That's as far as we could go. That's what we call simplified, right? Sometimes, I think there was a question on the homework last night where you couldn't do anything. It was already simplified. Number 10. This is the first example on the class opener of distributive property. And again, it doesn't matter if your multiplication term that you're distributing is on the left side or the right side. I still encourage you, whether it's on the left or the right, to circle it and draw some arrows. 7 times 5x. 7 times 5 is 35. And the x, you simply bring it down with it. Okay. Now, if you would have had an x over here, then you would have to multiply x times x and you'd get x squared. But there is no x. It's just the number 7 with the number 5, and the x comes down. And then the next one, 7 times 3, we get 21. Bring down the minus sign, and that's it. That's our answer for number 10, 35x minus 21. There's going to be almost identical questions to this on the test Friday. I think they're pretty easy distribution. Let's distribute the multiplication of x. X times y. Do I get x squared or y squared or... It's just xy, right? X times y is exactly that, xy. Because after all, if you don't put a symbol between it, that means you're multiplying. So right here, x times y, that's what it says, x times y. Let's distribute the x to the 4. X times positive 4, what do we get? Positive 4x. You see, it's easy. That's your answer, xy plus 4x. Now, you might be thinking, well, can't I add this with the 4x? The answer is no. Why not? Because this is an x and a y, and this is just an x, right? They're different terms. You cannot add them. Number 12. Number 12, a lot of people get confused with number 12 because we're distributing a number into a fraction. But we've already done this before, guys. Multiplying a number times a fraction is easy. Well, first of all, 15 times f, what's that? 15f. That's too easy. Let's get to the fun part. I want to take this 15 and I want to multiply it by the fraction 1/3. Now remember, a couple of weeks ago when we started multiplying numbers times fractions, make it look like a fraction by putting it over 1, and then you could multiply the top with the top and then the bottom with the bottom. So if I did go 15 times 1, what do I get? 15. And then if I multiply 1 times 3, what do I get? I get 3. And that's, of course, on the bottom. Now the plus sign is still between the two terms. Is that my final answer? If I can't do anything else, yes. But could I do anything else? Yes. What could I do? I could reduce, right? Or even better, think that the division bar is really the fraction bar is really a division bar. 15 divided by 3 is 5. So our final answer is 15f plus 5.
You can also do another way. If you know how you put it,
Yeah, so there's many ways of doing this. You could have done it a different way. Like when you were thinking, oh, I'm going to multiply this times this, you could have said, oh, reduce by 3, and you'd have a 5, and then multiply times 1, and you get 5. It's another way of doing it. There's many. That's the beauty about math, guys. There's many roads to the same place, many different ways of getting the correct answer. So this is a class opener. This is definitely a good idea to review once again before the test Friday, because a lot of these questions will appear on the test.